make sure it's out. Excuse me. Questions about this week? All right. So as I said, today we are going to do something called completing the square. Of all the methods for solving a quadratic, completing the square is probably used the least. However, there are some really interesting things that you can do with completing the square, including writing equations, which we actually won't do in this course, but will show up in future courses. So one of the things that you can use to help understand completing the square are something called algebra tiles. And I have some on my smartboard, but there is also a version of virtual algebra tiles, and they are loaded into your 9.5 folder, and I'll show you that here in just a second. Let's see. So if you go to the Schoology page and click on the completing the square folder, there's this virtual algebra tiles, and feel free to use them if they are helpful in doing your work. Some people find it helpful, others don't need it, but it's there. It's an option for you. All right, so here's what algebra tiles look like. So mine are labeled x squared, x, and 1. So it says use algebra tiles to model the trinomial. So I need 6 of these x tiles. So I think it's 6 of those. And I don't know how many of the red 1 tiles I'll need. We'll take care of that in a moment. And it says rearrange the tiles to form a square. Well, in order to form it's saying to form a square is a little misleading. What we're going to do is we're going to take and put some of these x tiles underneath the x squared. And some of them on the side of the x squared tile. And then what we'll do is we'll use the little 1 square to complete the square. And that's where the name of this method comes from. So we want to make this thing a perfect square. And this is where the perfectionist in me kind of takes over. Gotta have it lined up, gotta have it looking good. There we go. So we're gonna add these red 1 tiles. I'm gonna do my best to line them up nicely. And we're gonna fill in this little gap at the bottom. And the great thing is there's a method to know exactly how many I need, which we'll get to in a moment. And there it is. So I needed 9 algebra tiles, or 9 single 1 tiles. So that means if I had an expression x squared plus 6x plus 9, I could write that in factored form as x plus something squared. And actually, in this case, it would be x plus 3 squared. So that's algebra tiles, and that's how you can use algebra tiles to help you complete the square. I'm going to show you, and it's the algebra tiles work great for some examples and not so well for others. So I will also show you a method without using algebra tiles, how you can complete the square. So completing the square is a method to solve quadratic equations by rewriting it as a sum or difference of a perfect square. Completing the square is useful when a quadratic expression is not factorable and when a is equal to 1. So in order to use completing the square, we need to get that number in front of the x squared to be 1. And for the examples that we do, it will already be 1, just to make it a little bit easier. You may see more advanced quadratics where a is not 1 later in your studies. All right, and here's the method. And I think it's pretty straightforward. If we have some part of an expression x squared plus bx, and we want to make it a perfect square, we take b divided by 2 and we square it. And we add that to the expression. So if you think back to the example we did right at the beginning, b was 6. 6 divided by 2 is 3, and then we square the 3 to get 9. And that gives us our completed square. The factored form was x plus 3 squared. So that b divided by 2 is important to know because we can write our expression immediately in factored form. Makes it pretty easy to work with as far as finding our solutions. Oh, excuse me. All right, so here we're just going to complete the square. Find the value of c that makes the expression a perfect square, then write the expression as the square of a binomial. This really means write it in factored form. So to figure out what C is, we take B divided by 2 and we square it. Well, in this case, we have to do what's in parentheses first. So we do 10 divided by 2, which is 5 squared. So C would be equal to 25. So I like to write the expression. There is our expression as a perfect square. And then to write it as the square of a binomial, it's going to be x plus 5, the quantity squared. For letter B, C again is going to be the value we have for B divided by 2 squared. So, excuse me, -4 divided by -24 divided by 2 is -12. I'm going to square it. 12 squared is 144. Now, if you wanted to go from this perfect square form to the factored form, you could use the X method because A is 1. It would work, but it's always going to be X, and then in this case, -12 squared. So a couple of things with the perfect square form. This sign will always be the sign in our factored form. And then the value for C will be the value that goes there. All right, try a couple more here. C is going to be -8 divided by 2 squared. So this would be -4 squared, which is 16. So there's our perfect square trinomial. And the factored form, x minus 4 squared. Letter D adds a new little wrinkle. So here we're going to take b divided by 2 squared. And now 7 divided by 2 doesn't come out exact. So I'm not going to make it into a mixed number. I'm simply going to square the 7, make it 49, and square the 2, which makes it 4. And that would be our perfect square trinomial. And our factored form so make sure as you're working through these problems in the homework and the note check and things like that, that if you have a fraction, leave it as a fraction. You don't need to convert it to a decimal. I'm just gonna quadruple check that I have it that way in the homework. Yeah, left as a fraction. Good stuff. All right. So here are a couple for you to try. And again, I'll give you just a few minutes to attempt them, and then we'll take a look at answers. All right. So for each of these, for number one, C would be 121, and the expression would be x plus 11 squared. For number two, C would be 81 over 4, and the square of the binomial, the factored form, would be x minus 9/2 quantity squared. So that's how you get an expression as a perfect square. Now we're going to use that and solve equations. So in order to complete the square to solve an equation, we want to get the left side of the equation in the form x squared plus bx. And we always want the x squared to be positive. We don't want negative x squared. If you have a negative in front of the x squared, this method doesn't work. You have to do other work so that the x squared is positive. Then we are going to add b divided by 2 squared to both sides of the equation. The left-hand side will factor into the square of a binomial. So we'll have x either plus or minus something squared equals a number. And to solve for x, we need to undo the squaring. So we take the square root of both sides of the equation. Don't forget, when we take the square root, we get a positive and a negative root. That's important. And then the last step, get the x by itself and write your final answer. So let's walk through this example really quick, or not so quick maybe. We want to get the x squared and the x by on one side of the equation. We want to get the number on the other side. So I need to undo subtracting 8. So I'm going to add 8 to both sides. Now I'm going to take and find my value for c, which is b divided by 2 squared. In this case, b is 6. 6 divided by 2 is 3. And 3 squared is 9. And again, I like to write each step because it's going to help me as I move forward. So I have to add 9 to both sides. I want to factor and write the left-hand side as the square of a binomial. X plus 3 squared. 8 plus 9 is 17. I'm going to take the square root of both sides. What happens on the left is I'm left with just x plus 3. The square root and the square cancel each other out. On the right-hand side, I have plus or minus square root 17. Now I should check, does 17 reduce? Are there perfect square factors? And in this case, 17 has only a factor of 1 and 17 that divide evenly into it. So I can't simplify that radical expression. Get the x by itself. So I want to get rid of this plus 3. I'm going to subtract 3 on both sides. And I can't combine the square root of 17 and the 3. So it's just going to have to be written as this expression. So my solutions would be x equals -3 plus the square root of 17 and x equals -3 minus the square root of 17 as my answer. And I like to write the number first and then the plus or minus the root, because it leads to less confusion about whether or not the -3 is under the radical. Obviously, it's not. If I write it this way, we can tell that for sure. So very common that it's written in this form. So if they're given to you in standard form, where they're equal to 0, solving it becomes pretty simple. Again, we're going to get rid of the plus 16 by subtracting 16 from both sides. We're going to find our value of c. So that's b divided by 2 squared, which would be -7 squared. So I'm going to add 49 to both sides. X squared minus 14x plus 40. Ooh, that looked bad. Plus 49 equals -16 plus 49. The left-hand side I'm going to write as a binomial squared, x minus 7 squared. Excuse me. 49 minus 16 is 33. Take the square root. And I should see if I can remove any perfect square factors from 33, square root of 33. 3 divides into 33 11 times. Both of those numbers are prime. So I don't have any pairs, if I use my factor tree, that give me a perfect square factor that I can pull out. So this is going to be plus or minus square root 33. Last step then, add 7 to both sides. And that's the answer. Excuse me. Same idea here. Subtract 1 from both sides. Find our value for C. 10 divided by 2 squared, which would be 5 squared, which is 25. Add 25 to both sides. The factored form on the left, x plus 5 squared. Negative 1 plus 25 is 24. Take the square root, and then we'll simplify that in a moment, if we can. On the left, the square root of x plus 5 squared is just x plus 5. Let's see, 24 is even. So I divide by 2, 2 and 12. 12 is even, so I divide by 2, get 2 and 6. 6 is even, so I divide by 2, I get 2 and 3. So I have a factor pair of 2s, and then 2 numbers that are not a pair. So the way we write this, we still put the plus and minus, 2, and then 2 times 3 is 6. Last step, then we subtract 5. Again, do not think that you can combine the 2 and the 5. Not possible, because the 2 has that square root of 6 with it. So we get x equals negative 5 plus or minus 2 times the square root of 6. All right, so your turn. So go ahead and solve by completing the square, x squared plus 6x minus 4. And we'll look at the solutions in a couple of minutes. All right, so again, we want to get the x squared plus 6x by itself. Find our value for C. That would be 6 divided by 2 squared, which would be 3 squared, which is 9. Add 9 to both sides. Take the square root. And again, if we wanted to check the square root of 13, the only numbers that evenly divide into 13 are 1 and 13. So we can't take out any perfect square factors. Last step, subtract 3. And there's the answer. All right. So now what happens if we don't have it in standard form? So now we want to get the 14x and the x squared together and get the 9 by itself. We want the x squared to be positive. So the way that I would do this, I would subtract 14x from both sides. And now it's in standard form. So we can subtract 9. Find our value for C. Negative 14 divided by 2 is negative 7. If I square negative 7, I get positive 49. So I add 49 to both sides of the equation. I then factor the left-hand side. X minus 7 squared equals 40. Take the square root. X minus 7 equals plus or minus, and I want to simplify to see if there are any perfect square factors that I can take out of 40. 40 is even, so 2 and 20. 20 is even, that's 2 times 10. 10 is even, that's 2 times 5, and 5 is prime. So I do have a perfect square pair. So I'm going to have 2 square root 10, because 2 times 5 is 10. Now add 7 to both sides. And there's the answer. Excuse me. All right. Another way that this could, another form that the equation could take, we could have the x squared by itself. This is actually, I think, easier than the previous example. To get the x squared and the x together, here I'm just going to add 6x. Find my value of C, and we've done this one a few times. 6 divided by 2 squared, which would be 3 squared, which is 9. Add 9 to both sides. factored form, this becomes x plus 3 squared, and that's 68. Take the square root. I'm going to simplify that on the side here in a second. You get x plus 3 equals plus or minus, and now let's see if this has any perfect square factors. Now it's even, so we'd have 2 and 34. 34 is even, so we have 2 and 17. And one of our earlier examples, we had 17. We know that that's a prime number. We can't pull out any perfect square factors from the 17. But I do have a pair of 2's, so I can pull out a single 2 and have the square root of 17 left under the radical. I should say I have the 17 left under the radical. Subtract 3 from both sides. And we get our solution. And remember, this is actually, there are two solutions here. The one solution would be when we take -3 plus 2 times the square root of 17. The other solution would be -3 minus 2 times the square root of 17. All right, one for you to try. And again, I'll give you a couple of minutes, and then we'll take a look at the answers. All right, and so this one was, again, I think a little bit easier because it's already got the x squared and the x on the left. So I don't have to manipulate that equation any. I just need to start by finding my value for c, which would be -10 divided by 2 squared. Which is positive 25. So x squared minus 10x plus 25 equals -18 plus 25. Factor the left-hand side, x minus 5 squared. Simplify the right-hand side, -18 plus 25 is 7. Take the square root. Don't forget the plus and minus. 7 is a prime number, so 7 and 1 are the only numbers that divide evenly into 7, so we can't simplify that root any. Finish off by adding 5 to both sides. And there's the final answer. All right. So, questions? So what I will do is